Okay, welcome to my session on building a service from scratch, from the beginning when you just try stuff out manually in the CLI to eventually getting to a nano service where everything is done automatically through the reactive fast map process of NSO. My name is Simon, as Tree said, and I'm a developer for the NSO BU and the function pack BU. The agenda for today is to present one of the core function packs that we create as a pre-built package from the NSO BU, and of course what the intention is for the service that we're about to build, and then a bunch of different approaches to build this service. So first I'm going to start by doing it manually in the CLI, and then evolve into doing it through a template service that evolved from a very simple template service to a more advanced one where we use reactive fast map and kickers and concepts like that. And then evolving that service into a Python-driven service, also reactive fast map, and in the end up with a Nano Service version of the same service. So the service is going to be the same through all the steps, but the way of getting to the end goal will be more and more automated and using different NSO techniques. Briefly, to understand what this service does, we need to understand what Cisco NFVO is. I'm not going to go into super advanced details here, but just touch on the concepts real quickly. So Cisco's NFVO is our versions of the ETSI Nano Stack NFVO component, and ETSI is a standardization group in Europe that has something called the ETSI Nano, which shortly is a way of virtualizing network functions and the different components of that. And what the NFVO component does is two main things. It allows us to allocate resources for our virtual machine that we bring up. So that's the network function in this case is just a virtual machine. So it allocates resources on something called a VIM, which stands for Virtual Infrastructure Manager. And examples are OpenStack, VMware, AWS, Google Cloud, something that hosts virtual machines or containers or something like that, something virtualized. And the next thing that our package will do is instantiate the virtual machine on this infrastructure through something called the VNF, which is the virtual machine manager. In this case, it's called Cisco EEC, so it's another product of ours. There are three concepts I'm going to use through this session that is good to have some brief understanding of. One is a VNFD, which stands for Virtual Network Function Descriptor. That is a static blueprint of our virtual machine that gives us information on the resources it requires and the number of interfaces, number of virtual machines within it, and something. So a blueprint. Next is a VNF Info. That's a service in an NSO that takes one of these blueprints and instantiates it. So the VNF Info contains a pointer to the VNFD and then some real-world information on to which networks do you want to attach these virtual machines and which image do you want to use and stuff like that could change. And lastly, we have the resource orchestrator part that talks to the VIM, so in this case the OpenStack, to see the available resources on the virtual machine, on the OpenStack hosts or the computes of the OpenStack, and tries to find a good host match for our virtual machine. So basically trying to find where can we spin up this virtual machine on what the actual piece of hardware. The NFEO service flow works like this, as you see in the sequence diagram here, that the NFEO talks to the EEC, which is the VNFM, and asks it to create a VM. EEC in turn then speaks to OpenStack to actually boot up the VM. OpenStack tries to create it. In this case, it's a CSR virtual machine. It informs EEC that the virtual machine is up and running, and EEC then informs our NFVO component that the device has been deployed, but it is not fully booted. Next, ESC will start polling the booted virtual machine to see if it has started or not. And once it has started, basically when it has received its state 0 configuration and is manageable northbound, ESC will get a reply, send a reply to our NFEO saying that this VM is now alive and you can start managing it if you want to. So that's NFVO. Now we want to build something on top of NFVO. We want to build a service that finds a suitable host for us to spin up our virtual machine, which is a CSR 1KV. Then we want to add this device to the NSO device tree. This is done automatically by the NFVO function pack. And then we want to store some operational data that we receive from the device. And in the end, we want to configure the device with some configuration. Again, a sequence diagram showing the flow of this. The NFVO towards OpenStack and ESC thing has not changed, but I've added our service here to the left to show the flow that we will start with asking for an allocation for our VM. NFVO will ask our OpenStacks that we have configured to try to find some resources. OpenStack will reply with its resources, and NFVO will calculate which of all the computes on OpenStack would be the best fit for our virtual machine. And then it will give us this reply saying that for this VM, we recommend you using this ESC Y, a certain instance of ESC, and use host X on OpenStack. Our service should then use that information to create a VM on NFEO, and that is called the VNF Info that I talked about earlier. And then the entire process from the last slide starts where we boot up the VM, and once the VM is up and ready, our service wants to configure the VM. Okay, let's start with the manual approach of doing this, and I will jump back and forth a bit from the CLI and the UI to show you how I would go about to do this. So hopefully you should see my CLI now. And I will turn my head so I can see my main screen here a bit better. Okay, so remember the steps that you saw in the flow, that I want to first create an allocation. I want to get a response from the allocation, use that when I create my VNF info. I prepared this a bit, so to create an allocation, I create a bit of config. So I will load merge my allocation request and show you what that looks like. Compare. Okay, this is the allocation that I'm making. I'm making an allocation that I called dev days. And I say that I want to find resources for this VNFD. And a VNFD has flavors and instantiation levels, but don't pay attention to this. The important part here is that I want to find resources for this VNFD. Okay, so by committing this, nothing happens. At least that's what it looks like. But under the hood, NFEO is now talking to OpenStack and finding the resources for us. And if it finds something, it will give us some operational data of where we should spin up our VNF. So if I look at the operational data of the resource allocator, allocation for my allocation called dev days response, hopefully it has given us a response, and it has. It says that we should use, to spin up our VNF, we should use this host on this ESC. So this instance of ESC. This EC, the VNFM, this is actually a device in the device tree in NSO. So if I do a show device ESC, we have one here in our device tree called ESC. So it basically just tells us that when you instantiate your VNF info, you should talk to this ESC and you should use this host for spinning up the VNF. So let's do that. And of course I've prepared this as well. So I'm going to show you the VNF Info Service, how that looks like. Okay. The details of what this contains isn't that important for this session. What is important though is that it's a VNF Info Service called CSR that I want to spin up using the ESE0, and I want to call the device CSR once it's onboarded on the NSO device stream, and I want to spin it up on this host. You might notice that the resource orchestrator gave me the host number 3, and here I'm using host number 2. This is because I prepared this on previously, and hopefully it's going to work with this host as well, even though I'm not taking the one that the orchestrator actually gave us. But I'll take my chances here. Okay, so by committing this, the entire process will start happening with ESE and OpenStack to spin up an actual virtual machine here for us. Okay, this takes roughly 3 minutes, and we have a plan for this service that shows us the state of it. And let me go to the UI real quick and show you what that plan looks like for our NFEO service here. VNF Info, I called it CSR. So this is the plan. There are a bunch of different states and components in this plan, and but what we are interested in is, of course, when all these different components have turned green. Now this takes roughly 3 minutes or something like that. So I've cheated a bit. So before the session, I actually did all this with another service that I called CSR Cheat that is already up and running. So that means that if I have a CSR Cheat up and running, I should have a device in my device tree also called CSR Cheat. And if we go to the device tree, we see that that is the case. We actually see the CSR that I just created as well, but so far it doesn't have an address or anything like that, and that means that it's not up and running yet. We are still waiting for it to complete. Let's go back to the CLI real quickly. So the last thing I wanted to do was to configure the device, and let me with some data. Let me show you the configuration that I want to load here. CSR config, compare running brief. It's a very simple configuration that I've added. I've just said that on device CSR, I want to configure the SNMP server, community public, read-only. That's all the service does. I also want to get some operational data from this device, and our VNFM actually sends us this information and we store it in the NFVO as operational data. So let me show you quickly what that looks like. And I'm going to use the CSR cheat that I created previously. It's a bunch of different information, but you see the different interfaces we have here. We see the IP addresses of that interface, MAC address, gateways, and some other information that you might find useful. In this case, I'm interested in the IP address. I'm interested in the gateways for the interfaces. Oh, we got an internal error. I hope that's okay. Let's ignore that. Okay. That was the first part. This was creating everything manually. If we are lucky, it is actually up and running now. If I go to my CLI, yeah. So you can see here that the CSR is now up and running, and everything worked. Let me go back to the CLI and actually delete this because I don't want to use too much resources in our lab here. VNF Info CSR. I'll actually delete the cheat one that I created before as well. We don't need that anymore. I just wanted to have it as a backup if things did not work. Okay, so that was the manual approach of doing this. Now we want to go into the more service approach of doing it instead of me going into the CLI and loading files and all that. What I usually do before I write a service is to create the steps of what I want my service to do. So I've listed the 7 steps that I could come up with for our service here. And the steps are that we need a plan. A plan in NSO is, of course, the way to show progress of a service. I want to create an allocation. I want to wait for the allocation to be ready. Once it's ready, I want to fetch the information from the allocation, which in this case would be the VNFM to use and the host to use. A host in this case is the compute of OpenStack, where we should spin up the VNF. I want to wait for the VNF or the virtual machine to be up and running. Once it's up and running, I want to configure it and update our plan to say that the device is up and running and configured. And then I want to have some operational data to show. But firstly, let's start from just creating a simple service. Hopefully you've created services before and you know that we have a bunch of tools to help you get started with creating a service. For example, you have the Linux command NCS make package that gives you a skeleton package. And that's basically what I've done here. I created a very simple package called our service. I created a list in our service called our service with just a key that's the name of the service and nothing else. And I've added the NCS service data and service point to actually make sure to tell NSO that this is actually a service and not just some configuration to be stored. Next, I want to create the service itself, so the service does something. And I'm starting out with a template service because I just want to make something simple. I don't want to have code or anything like that. So I start out by creating the config template skeleton, and I tell in the attributes, I say that this is a service point. This is a service, and I bind it to our service point that we created in the YAM module. And then I need to put something in the service, of course. So here I've just copied the XML version of our service that I created previously in the CLI. So running this service, it will apply this configuration on the VNF Info Service. So it becomes a stacked service. Now, the best way to get this information from the CLI, for example, is to make use of the show command, show NFV info CSR display XML. That gives you an XML representation of the service configuration, and you can just copy this and put into your service. And you'll see that that's exactly what I've done here. I just took whatever this CLI put out and I put it into my service. But I want this to be a service that can have multiple instances, so I don't want to hard code some of the values. So what I've done here is that instead of using a hard coded name, I want to use a name that differs depending on the service name. I use a variable here called VNF. And to create this variable, I'm using some processes instruction that NSO has for templates. So the set instruction allows me to create a variable. So I say set VNF to create a VNF variable. And I want the variable to be a concatenation of the name of the service. So this corresponds to the input name of the service in the key of the service. And I add a dash and I add CSR to just for some readability. And then I reuse that variable in the VNF for the name of our VNF Info Service, and I also reuse that variable for the name I want NSO to use when it onboards the device in the NSO tree. And yes, let us add this service to the device tree to NSO just quickly here. Or okay, actually I already did that, so we don't have to see me onboarding the package, but the package is already onboarding in NSO. That means I should have something called our service here. And I'll quickly just show you that my naming convention works, that the name of this service actually creates a unique name for the underlying service later on. So I'll just call it dev days simple template. And that's it. And then I do a dry run commit of this, and we'll see that the configuration that this tries to create is the, oh, I had some old service there as well. So okay, let me do this. Reverts, so we don't get too much information. Let's do this again. Commit dry run. Here we go. My service would then create a VNF Info Service, and that's what we want. It will use the name of our service that we created up here and concatenate CSR to it, and it will use this name as well for the device name here. Perfect. That's all I wanted. I don't actually want to instantiate this because this actually does what I did manually. So we'll skip that to save some time. But going back to what I actually wanted to do, looking at this list, I want to make this more automated. So I want to have a service that can apply different parts of configurations in steps. So I want it to be reactive, hence the reactive fast map. So let's first evolve our service a bit by adding another leaf. Let's add the allocation leaf to our service. Other than that, it's exactly the same as before. It just has the name of our service, but we now also have a configuration called allocation. And this will be the name of the allocation I use for our VNF. So like I showed you in the beginning, I create an allocation with a specific name, and that's going to be this name. Okay, I added all the steps that I want us to perform in our service, but step 1, 2, and 7, we won't do them in this service, and I'll briefly tell you why. So if you have a pure template service, you cannot create plan states. You need an API for that using Python or C or Java, or you actually need to use Nano Services that we'll show later on. So we can't do step 1, and we can't do step 2. You might ask yourself, why can't we do this? And the reason is that each time you redeploy a service, the configuration is torn down and recreated each time, and to calculate if has been any changes. And the way the resource orchestrator is being created is that each time you delete an allocation, you also delete its response. So we cannot create an allocation and check the response for it in the same transaction. But all of the other steps we should be able to do. We should be able to wait for the allocation to be ready. We should be able to get some information from the allocation, and we should be able to wait for our VNF to be ready. So let's go ahead and do that. Okay, I tore down everything just to make it really clear, and then I'll try to do the steps one by one. So first, wait for the allocation to be ready. I'm using the if statement here, which is another of the process instructions that we have. And I'm using XPath to ask NSO and NFEO if this allocation that we have is done or not. And I'll show you how I invented this this XPath expression in a few minutes. But let me quickly just show you what it does before we say how I actually got the path. So it's a negation here. So I'm saying if this allocation is not ready, then I want to create a kicker. So if this is not true, create a kicker for me. And again, I'm looking at the same path here, saying that tell me when it is ready. So if it's not ready, create a kicker, which in NSO is a built-in declarative subscriber. So I'm saying if it's not ready, tell me when it's ready, and then redeploy the service. Now, the way I came up with this expression here, the XPath expression, is I actually went into the CLI and I created an allocation. So let's load our allocation again, called alloc. And then I displayed the allocation in the CLI again by doing show NFE resource allocation. It's called dev days. And I did a display XPath. By doing that, I got the exact expression. So when I was interested in to see if the OK configuration had been created. So I basically just took this line here and copied it into my XML file. As you can see here, it's the same configuration that you see here. One difference, of course, is that I want to make it dynamic. So instead of having a hard-coded ID, I pick the allocation leaf from the service. So that's what this does. And briefly on context, since we are in the context of our service, I need to step out of the service, hence the dot here, to create the kicker. I'll go more into that later as well. Okay. Next, we want to create our service, and quite a lot is going on here. First, the if expression now has an else part. So if it actually is up and running, if we have an allocation, we don't want to create the kicker anymore. So the kicker is being removed, and instead we want to create our VNF info. And we also want to fetch some information from the allocation. So quickly on context here. So I said the service context is actually the context we are in when you have a template service. And to make it easy to fetch the information from the resource allocation, which is in a different context, I want to switch context. So the first thing I do here is that I save our current context to a variable called service. Then I switch the context to a different node in the NSO device, in NSO configuration tree. So I set the context to our resource orchestrator instead. And then I bind two variables to the response in this resource allocation. So just like I did with the kicker, I have the exploit expression that points to the virtual computer I want to use for the VNFM and the host I want to use. And I save those into the VNFM and in the host variables. And then I switch back context to the service context. Looks kind of complicated, but it's kind of neat if you want to quickly switch contexts and get more than one value. If it's just one value, I'll use the relative path like I did up here and just dot myself out of the context. Next, I'm using those variables. So just like before, I'm using the VNF variable for the name and for the device name. But now I'm also using the host variable and the VNF variable in my service. So that is no longer hard-coded. So slowly we're getting to the automation level I want to achieve here. Next, what we want to do is to wait for the VNF to be up and running. Now to know if it's up and running or not, I look at the plan. So I showed you the plan for the VNF info in the CLI, in the UI, but it is of course also available in the CLI. So if I go to my CLI and do a show NFE VNF Info Plan. Let's take one of the ones that's booted. Python here. It has a bunch of different configurations. What I'm interested in is if the self component of the plan is ready reached. And again, I use the trick to do a display XPath here to give me a good, suitable easy way to figure out which XPath expression I want to use in my if condition here. So this is basically straight up taken from the CLI, but I've changed the name value here to actually be the VNF variable that we created above in the service. So here I'm saying if it's not ready, create a kicker and tell me when it is ready. And once it is ready, redeploy the service. Once that is done, I want to configure the device. So if this expression is not true, if we go into the else statement here, it means that the virtual machine is up and running, and I want to go ahead and configure it. Now this will not give us the operational data because even though it's quite possible to do it here, there's some for loops and all that. So I thought I would skip that for now to not pollute the slides and use that in my Python code instead. Okay, to save some time, I'm not actually going to show, or let me actually do that real quick here. This one is not preloaded, so I need to add this package to our service here. I'll remove this service, and I'll add the one that we've just created, our more advanced template service. And I will reload the packages in NSO so we get the new package. This takes roughly a few seconds here. Hopefully it works. Okay, everything froze. I hope it's just temporary. Okay, good. It just took a long time. Good. That means that we now have a new service. It's actually the same name as before, but we should have an our service that we now call a complex template service. Service, and it needs an allocation. So let's call it complex as well here. Now, if I do a commit dry run here, you'll see that nothing actually happens, because the only thing this would do is to create our allocation. It would create the kicker actually. So let me go ahead and show you that, just to prove that something actually happens. It's hidden, so I'll unhide it. And kickers are just configurations. So we should now have a data kicker called our complex service, which basically says that when something is added, or did I take the right one? Yes, when something is added, we want to be kicked. But nothing, we didn't have the allocation now, so nothing would happen. But let us go ahead and actually create this allocation. Let me just really quick see what the service name was here. It was called complex. So I will create a resource allocation called complex, and hopefully a request for a VNF called CSR basic. And by committing this, hopefully our service will start, which means that we will actually start getting something. It's kind of hard to show you this, but what actually happened now was that my service got kicked. So this service actually ran again. And when it did that, it created a new VNF info called complex template. So this was actually created now. And if we look at the context here, we see that it chose an ESC for us, and it shows some placement, and it shows the VNF we wanted, and it chose a good placement for us. And hopefully, if we look at the placement that our resource orchestrator gave us, it said that we should use the host name micro IEO2, and that's exactly what the service worked. So it worked. That's perfect. And if we go to the UI, hopefully we would see this service slowly being added here. Yeah, so this is the complex one, and it's slowly starting up. That's perfect. I don't think we have any questions, so I'll continue. Otherwise, just shout out that I should stop. But like I said, there are a few things that we didn't do here that I want to do. We didn't create a plan for our service. We didn't actually create the allocation. I had to do that myself to get the service up and running. And we did not store some operational data. So the next part is to redo our service once again, but this time we want to use some Python code to be able to create the reactive fastmap part and kind of move away from the complexity of the template and move into Python code, which might be easier to read. The service this time looks pretty much the same as before. I've added the plan data because I want this service to have a plan. And I've added some operational data that I want to store. So basically here, I'm just storing the interfaces, the address and MAC address and gateway for each interface. This is what I want our service to display northbound later on. I've also added a bunch of states, so 3 states that I could think of, mainly from the list that I created before on what I want our service to do. So I have an allocation state that tells me when the allocation is done. I have a VM run state that will tell me when the VM is up and running. And lastly, a state called VM config that tells us that the device is actually configured. All right, so this was the advanced template that we had that did basically all this, but not the actual state parts, the plan part and the operational part. But this time I want to do the same thing in Python. So I have a Python skeleton here where I wrote all the steps. And as you can see here, I said that step 1, 2, and 7 are now possible to do. And instead of registering the service in a template, I'm registering the service in the Python, the starting object of our Python application. There is also a bunch of different helpers that I've written here that helps me find the information of like, is the allocation ready and is the VNF ready? That does basically what my XPath expressions did before, but in code instead. And I'm not going to go into the details. You just have to trust me that those APIs works. And later on, I'm going to share all this code with you so you can take your own time and try to figure out what the code actually does. Okay. Let's start with what the number 1 on our list, and that is to create the initial plan. To do that, you create a plan component in Python. And for each state that we created, you append those states to your plan. So each plan always have the self component that's from that NSO gives you. So to all these self components, we add the different states. The only states that I created in our Yang modules were these 3 states. And the init and ready states NSO gives you, and you always have to have them. And once your service is up and running, your init state should always be reached. So that's why I instantiate everything by creating all the states and setting the init state to actually be reached. Next, I want to create the allocation. Now, creating the allocation, I could either do this through code, but here I'm applying a template, so I could reuse the assets that I used earlier. So I say that, so in my service, I created something called the Our Service Python RO template that looks like this. This we didn't do before in the template service, but we did use it in our manual process. So the configuration should look similar, that I create a config template, and I create a resource allocation. I'm using the name allocation from our service, and I want to find a suitable fit for this VNFD. Next, in our service, I want to wait for the allocation to be ready. And here, the waiting is basically doing the same I did in the XPath expression in our template service, but instead I'm using it code. So I'm trying to see if our allocation is not ready, create the kicker, just like I did in the XML part. So again, I've created a kicker, and this time it looks exactly the same as it did in the template service. So I just copy pasted that into here. I root everything else, and I only keep the kickers part. So there's no if conditions or anything like that, because the Python code now dictates whether or not this should be applied. Next, I want to create the allocation. I want to use the allocation response. So basically what happens here, that is, I'm creating the kicker that says that if the allocation is not ready, kick me when it is ready. So when we're here, it means that we were kicked by the kicker. This allocation is now ready, so we don't go into this part of creating the kicker, and we update our plan to say the allocation is up and running. And then we fetch the allocation information using the get allocation info function that I wrote that does the same thing that my complex switching of context and fetching the VNF and host from the resource allocation response. That's what this function does. And it stores them in the host and VNF variables. And then I add those VNF variables to the variables I want to use in my templates, and then I apply that template. And that template also looks exactly the same as before, but without all the complexity. It's just the service with the different variables we want to have substituted for each instance. The next step is to wait for the VNF to be ready. So again, I'm creating a negative, a not, if it's not ready, create a kicker for it to be ready. And the kicker again looks exactly the same as before. Wait for the VNF Info Plan to be ready. Once it is ready, call our service again. And if we are ready, skip this step, next round of the service, update our plan to inform us that the VM is running, apply the CSR template, and set our service to reached. And the CSR template just looks like this. We're just configuring the public community leaf with read only, and we're using the variable that we created before to know which device this is. And lastly, in the end here, I'm doing step number 7, and that is to fetch a bunch of operational data. Again, I'm using some predefined function here that gives me the device from the VNF info result plan, and I loop through all the interfaces and I store that in our service. I see that we're kind of running out of time, so I'm skipping instantiating this and just showing you the result of this service because I created one before. So if I show you our service Python sheet CSR cheat because I cheated and created before, you can look at its plan and see that all the different states of the service is done. We passed the allocation, we passed the VM run and VM config, and it's now up and running. That means that the device is configured, and it also means that our service should have some operational data that I'm interested in. Basically, for each interface ID, we have an address, we have a MAC address, and we have a gateway. So perfect. We know that the service works. Okay. Finally, I'm going to do the same again, but using a Nano Service. So let's look at the YANG module for Nano Service. I haven't changed anything from the previous service in terms of having the allocations, identities for the plans. Everything is exactly the same, but instead of having plan data, I've added a nano plan data, which tells NSO that this is actually a Nano Service. Other than that, the service is identical to previously. Now let's go ahead and actually create the Nano Services here. First, to create a Nano Service, you create something called a plan outline. And here I define all the states I want our service to have. First, I say that for this component, and we only have one component in this use case, I have all these different states. So this is basically similar to what I did in Python when I just created the states. Just briefly, each Nano Service needs to have a service behavior tree. And I'm not going to go into the details here, but what a behavior tree does is that it actually creates the above plan for us. So, and it also gives you a nifty way to store some variables. So I'm fetching the allocation value from our service, and I store it in the allocation variable, and I create the VNF name just like I did before by concatenating our service name with CSR, and then I create the self component. Next, I want to start doing stuff with our service. So I want to be able to create the allocation. And to create the allocation, I need to define a nano callback. And a nano callback tells NSO that this state actually needs to do something. And somewhere there's something registered to do this. And here I'm switching back to the template approach again. And registering each of these different service points in a template. And just like you did for a normal template service, you need to have a service point, but you also need to have a component type this time because it's a nano service, and a state, which basically tells you that for this component type and this state, I want to do this. So again, we're applying a bit of configuration here called for our allocation, just like we did in the Python version. And then we need to wait for this to be ready. And to do that, in the step after, in the state after, we add a precondition. We say that don't create this state until this has happened. And you probably recognize this monitor statement. It's the exact same statement I used for the kickers, but this time there's no kicker involved. Or there is a kicker involved, but you don't have to create it yourself. The kicker is actually created by the Nano Service for you. So when the Nano Service goes here and read this precondition and tries to see if does this monitor value exist, yes or no. And if it does not exist, then go ahead and create a kicker for it and stop the service, just like I did manually in the Python version. So I just want to highlight that you don't create kickers anymore, and Nano Services creates kickers for you. Next, once the allocation is up and running, we actually want to do something. And again, we're using a template, same service point, but this time it's for a different state. And to avoid using code here, I'm going back to what I did in the complex template by fetching the allocation values myself. So I store the VNF and host variables from within the template in itself and reuse them. So I kind of went back a little bit here and re-added the kind of complex processing statements of switching context and then fetching the variables. But this will be applied once we reach this state. Next, we want to wait for the VM to be up and running. So for the VM run state, I again add a condition that again looks exactly like the condition I had before with the XPath to wait for the VNF Info Plan to be up and ready. And once the status leaf is of this plan component is reached, I want to go ahead and do something else. But if it's not reached, Nano Service will go ahead and create a kicker for us with this expression. And once it is ready, it will run the service again. So again, I don't have to create the kicker here. And once it is ready, I want to do step number 6, which is actually configure our device. Again, I just took the template version of creating the configuration for our device and I register it to the VM run state of our service. And finally, we want to fetch the operational data and store it in our service. And we don't need we do need preconditions. We don't need the preconditions here because this happens after we configure the device. We're not waiting for anything more. And to do this, just to show you that you can mix code and templates, I actually went ahead and did this in Python. So I registered this Nano service in Python instead. So the VM config component state of the self component calls this snippet of code. And this time, the only thing we do, just like we did in the Python example, I loop through all the interfaces and I store them in our service. And that's it for the service. Again, we're running out of time, so let me just show you that I actually created a service like this. That's before that's up and running. That's called Nano Cheat CSR that has a plan. And the plan is very similar to the Python version. Let us compare. Briefly here, Cheat CSR. Python Cheat CSR plan compared with the new plan. So there is you now have some more data that the Nano Services needs for backtracking and stuff like that, but the actual states are the same. We have the init state, we have the states that we've created, and we have the ready state. And hopefully our service also has the operational data. Yes. And yeah, that's it for this presentation. I went from doing something manually and ended up doing it automatically through a Nano service. And do we have any questions? Otherwise, I think you'll have to give us the questions some other way later on. All the code for this I will make available for you somehow. I'm not entirely sure how at the moment, but I will talk with the organizers of the event on where I can share all these basically 4 different versions of our service, so you can look through them yourself and reuse them if you want to.
We'll post a link on the YouTube chat.
Okay, I'll post a link on the YouTube chat. Perfect. Okay, thank you.